Good morning, mathematicians. I'm feeling a little under the weather today. My throat is a little bit sore, only a very tiny bit. I'm supposed to give a short talk later today, so probably cap today at like 20 minutes, 30 minutes. Maybe I shouldn't even be yapping online right now anyways, but I don't want to let y'all down, I don't want to let the algorithm down, the almighty YouTube algorithm. It holds power over me. So, let's get into the local Artin map. Now that we did a speed run of ramified extensions. So we have this pair, satisfies the hypothesis of Tate's theorem. And so we have the following result. Artie boy. Boris, what was it? I don't know if you saw the recording from yesterday, but there was something. Oh yes, it was. I was starting to agree with you that Z into Q mod Z is everyone's favorite short exact sequence. So I thought you should know that. I'm declaring it publicly. Every finite Galois extension of local fields, we have this isomorphism given by cut products. And when R is minus 2, that recovers this statement. Yeah. Great. And then, of course, if we have a tower of extensions, then the homomorphism commutes with both the restriction and co-restriction. I think we had proved theorems like this quite a while ago. Good morning, Arad. Osam was busy mathing yesterday. Well, that is the only acceptable excuse. Actually, I feel like people have given me several different excuses, and I've told them that's the only excuse for missing my live streams. So there's more than one, I would say, but that's definitely probably the best excuse to skip my live streams. Julian A. Any advice on undergrad math major on how to get really cracked? Highest math level analysis / topology. I guess it's no secret, really. It's just hard work, right? That's really what it comes down to. Is just hard work and rest. Rest is important, right? I mean, I often forget this. Maybe this is why I've got a sore throat today. But, your muscles do the most growth when you take like a rest week from the gym. So, this happens too mentally. But, how to get really cracked at analysis and topology. I mean, there's a lot of weird exceptions and stuff in analysis and topology. So, taking a look at books like there's a book called Counter Examples in Topology. Be familiar with all of those counter examples and be able to prove the statements as well. But at the end of the day, it's really about solving lots of problems, spending a lot of time solving lots of problems. I think you need to set aside some time for reading ahead, reading things that are maybe just a little too advanced for you or something, getting a sense of what's out there. Going to talks is important, trying to do research and stuff. But these are all secondary things, right? The fundamental backbone is just sitting down with a piece of paper and doing some mathematics, right? But that should be the core. That should be the bulk of what you're doing with your time, right? If you want to get good at mathematics, you should practice doing mathematics. But these secondary things help. Raw dog Hartshorn, sure, might not be ideal for analysis / topology, but yeah, Boris, yeah. I mean, to be fair, I'm saying this, and it's not like I've followed this advice perfectly, but I still feel justified in saying it because I know that when I do, I don't follow this perfectly, but I know that when I'm learning something like this Galois Cohomology on live stream or any other subject, it's when I stop and slow down and do some basic exercises and just write things out carefully that I end up internalizing these things a lot more. So raw dogging Rudin did more good for you than anything, and you don't even like analysis. Yeah, so there you go. Dive into Rudin. Understand as much as you can in Rudin very deeply. Oh, you meant those are the highest math levels you have reached. I see. Okay, already taken both. But check out the counterexamples book. Your goal is to understand modular form / Galois / homology, cohomology. Well, then, yeah. I mean, huge fan of growth and Deke especially. Yeah. Well, then start, definitely Galois theory is the basis of a lot of those things. So, start with Galois theory. It's always a delicate balance of, trying to figure out when do you... Yes, step one is shave your head. Actually, is that step one? I feel like he did a lot of crazy things well before he shaved his head. But, yeah, there's always a delicate balance of, like, if you spend too much time on the basics, right? Like I feel, I could be wrong, but I think a lot of people who are like going to top institutions at a young age and stuff, I get the sense that they're actually black boxing a lot of information to get to the cutting edge of research and start doing research at the cutting edge and then backfilling a bit on the way because it's just so much to take in. At the same time, you do need a solid foundation in the basics. So I would go pretty hard on the basic group theory and Galois theory there. But, do set aside some time to read ahead about modular forms and homology and cohomology and things like this. True, that was the most tame thing, but it's still a necessary step to becoming a math god. Okay, so we've got... Anyways, finally getting back to some Galois cohomology. We've got, compatibility with inflation, restriction, cut products, things like this. Wait, how's that different from what he said above? It seems like he's just saying the same thing twice. And the inverse map is what we call the local Artin map. You've already ran into several master's students working on like state-of-the-art stuff. Although we're working on state-of-the-art stuff right now, one could say. I think you're really forced to jump ahead and block box to get anything done. Yeah. I feel like I'm caught in a weird gray zone where somehow I didn't block box enough, but somehow too much. What do I think about Growth and Deke's method of like cracking a nutshell by submerging it into water and having it become trivial? Hello, Thomas. Here's what I think, and what I've noticed in myself and what I notice in others. We have these idols, people like Grothendieck, and he's this god. So you might want to be like him and emulate him, right? But your true nature just may be, there's many different kinds of mathematicians, right? Problem solvers and theory builders is like one major divide, but there's so many ways that you can cut up this pie. That sounds very cool, Thomas. That sounds very cool. Seems like you're learning cool stuff. But you need to take an honest look at your true nature, right? You read these romantic passages from Grothendieck about his philosophy of mathematics and the way he likes to do mathematics. And it's perfectly fine to aspire to that, but you may find that naturally you're just not built that way. Naturally, you're just not built that way. Maybe you are just not much of one for theory building, but you have great talents in like computational power, and being able to work through difficult examples that other people can't, right? So, of course, I read Grothendieck and these romantic quotes, and it's very nice, and it'd be lovely to be like that and build this crazy deep theory. But I also just don't know if that is what's in me. I don't know if that is what my strengths are. Of course, you can build up your weaknesses. You have options. To play to your strengths or build up your weaknesses, whatever. But I do think, you just need to be honest with yourself, which is a hard thing to do. Hardly delude yourself into thinking you could be any one of the greats. Well, but also, don't be too pessimistic, because, sometimes I feel like the people who get things done in this world are the people who just believe in themselves, perhaps too much, who have an inflated sense, because you need that sort of deep belief in yourself to push yourself through. So be mindful of that. I was just been yapping for like 5 minutes. Boris put it much more simply. If you're not Grothendieck coded, you'll just end up with wet nuts. Yeah. Okay. So we've got our Artin map. It's defined as this inverse isomorphism, and that isomorphism was compatible with a whole bunch of with various structures. So perhaps it's unsurprising that we have these commuting diagrams over here, induced by these inclusions. Self-deprecation phase over. We self-aggrandizing in this hell now. Absolutely, Boris. Absolutely. Everyone in this live stream right now is the greatest. Well, too bad, Julian. You're being dragged along in the lack of self-deprecation. Proof to be added. The second is not really needed. I see. It should be pretty straightforward from the whole preceding paragraph, right? We should also have a diagram here. The unmarked vertical arrow is their surjection. Seems very believable. This follows directly from the definition of local Artin map using 33, So, if we have a tower of finite abelian extensions, then this is true. So we can define phi k to be the homomorphism such that right, so this is the maximal abelian extension, I guess. Right. So then just defining it by its restriction to each field uniquely defines it. And so that gives us the local Artin map here. Makes sense. In particular, every prime element of K will get sent to Frobenius. And for every finite abelian extension, this norm is contained in the kernel of this map. And that's what induces the isomorphism. Well, I mean, Julian, imagine, I don't know if you have like young kids in your life, nephews or something, or cousins, but like, I don't know, imagine you were explaining the topology that you know to a sixth grader, right? Like, imagine trying to explain, I don't know, the non-Hausdorffness of the finite complement topology. But here you are knowing that topology, right? And then that sixth grader you're talking to, very easily, it's just a function of the time that they've had on this earth to read these words. And so actually, and in fact, the gap between you and the sixth grader is probably larger than the gap between you and understanding this paragraph, I would say. Amoeba Max learning by osmosis is underrated. Yeah, I tried that. When I first went to university, I used to fall asleep to Leonard Susskind's lectures on string theory. I don't think I actually retained anything. But I love his accent. He has such a nice voice to listen to. Hausdorff spaces was one of your favorite topics. Topology was so fun. Yeah, topology is pretty cool. Exactly. It is all perspective. So, and you can go back and watch the beginning of these live streams and try and speedrun Galois Cohomology yourself. Yeah, it is the buildup of knowledge, yeah. Yeah, calculus is a bit of a leap. It definitely requires, yeah, it's all like that. For those who have read section 3 of chapter 1, that's not us, we skipped it. Wee you, bad boy alert. This completes the proof of the main theorems of local class field theory. We can now skip to chapter 5. Yay! Oh, but that's only if we read chapter 1. Damn it. Well, we're bad boys and bad ladies and bad NBs, possibly. So we can break the rules if we want to. Others will need to continue to the end of chapter. God damn it. That's us. We're the others. We're the others. Okay. Let's continue the end of chapter. How much more we got to go here? Maybe we'll get to alternative description of local Artin map. That's where we'll cut it off. Norm limitation theorem. There's limitations on our norms. If L is a finite extension, and let E is the largest abelian extension of K in L, then the images of the norms are equal. Okay. Books with dependency graphs at the start are super cool. That's true. That is true, yeah. Because of the transitivity of the norm map, this is a subgroup of this, right? So maybe if we can just show the orders are equal, right? Do I have an intuitive breakdown for what Galois cohomology is? You seen homology, cohomology, but I've never quite understood it. That's actually a good question. And actually, even though I've been doing the stream for a little while, in some sense, I'm still not really sure. And I was asking a friend of mine about this, like, well, what makes it Galois cohomology? And I guess the answer he gave is correct. Is basically you're looking at group cohomology, right, of Galois groups, and specifically you're looking at actions of Galois groups on abelian groups that tend to come up in number theory, namely the action on the additive group of the field, the multiplicative group of the field, the units, the ring of integers, and all sorts of other things. So let's see what Arad has to say. If E over F is an extension, stuff over F can be pulled up to E. Galois cohomology is sort of concerned with going in the reverse direction. Oh, that's interesting. That's an interesting perspective. So it's sort of like descent. I guess you could talk about it. I guess that tracks, right? Something descent theory, something cohomology. So I guess if we viewed the scheme theoretic version, well, no, the scheme theoretic version of E down to K, yeah, I guess it's like, yeah, I guess it's like some sort of descent, because it's like spec E down to spec F. Right? Okay, good. What's so special about Galois groups in the context of group cohomology? Well, I think it's just that group cohomology, it's not that Galois groups are special in the context of group cohomology, but almost the other way around. Like, group cohomology is a powerful tool that applies to all groups. Galois groups are, specifically meaningful. And so we apply the powerful tools of cohomology to the specific instance of these certain realizations of certain groups that we're interested in. So I think that's the way to think about it. Okay, so let's... I'm going to try to finish this proof so I can go. So if L over K is Galois, then this should be the abelianization of this. So theorem 3.1 shows that the norm subgroup has index in here. Okay. Yeah. Makes sense. Wait, aren't we done? Oh, no, because, I see. There wasn't the Galois assumption here. We said if it's Galois, then we're going to piggyback off that for the general case. If L prime... Okay, so then we take a Galois extension containing L. We take these groups. We take this. And then E is the largest. Then E is the largest subfield. Wait, what's our setup here? L is any finite extension of K, and E is the largest abelian. Then E is the largest subfield of L that is abelian over K and contained in L? Sure, right. So therefore the subgroup of G, fixing it, is G prime H. Wait, and H is which Galois group? Sure. Yes, okay. I can believe it. And H prime is the derived group. Okay. So now we take something in the norm of EX. We want to show that it's in the norm of LX. And we consider this commuting diagram. Okay. meditation time. How do I get the Jeopardy music? Is that copyrighted? Anyways. Okay, Hmod its derived group embeds into Gmod its derived group. Surjects onto this. I agree. Then, okay, those are all those corresponding maps, and we should have some compatibility with norm. Okay. Then this element of Gmod G maps to 1 in here. Unclear. You have a terrible problem of setting a scope for writing blog posts. Maybe you should give up on the big ones and just get to some of the shorter ones. Yeah, I think that's always a good strategy for anything. Attack the bite-sized pieces first. I don't understand the statement, though. Oh, right, because A is in the image of the norm map. So I guess it'll be in the kernel, by the commutativity, it'll be in the kernel of this. Well, this isn't he doesn't say this is exact, though, does he? Oh, but I think it is. Just by it does force it to be in the kernel. I think if you look at this, you're starting to get it a bit, at least insofar you're as being able to relate it to sort of the global idea of regular cohomology. Yeah. Well, I mean, group cohomology is kind of its own thing. Well, yes, but not really. I mean, technically, historically, it evolved out of the topological cohomology of classifying spaces. But cohomology, in this sense here, is much more general, not necessarily something about detecting holes in shapes. I do actually have a couple videos on my channel where I talk about cohomology. I think I have like 2 or 3. Descent along covering spaces in topology is perfectly analogous to descent along field extensions. This is true. But yeah. Okay, where was I here? Okay, I convinced myself this sentence was true. And because this is surjective, we see from the diagram that there's a B in here, such that these things are true. Yeah. Yes, there is a B that does that. Sure. And hence, A over norm of B is in here. Because this... Right. Because this is a homomorphism. So sure. So call it some C. Why are there so many Galois connections? Someone called the adjoint police. Yeah, I better end stream before they get here. Oh crap, they're knocking on the door. The adjoint police are here. uh, uh, uh. Wow. There is no hope, everyone. Remember this as you go about your day. Let the words of Milne wash over you. There is no hope. Theorem 3.5 shows there is no hope of classifying non-abelian extensions of local fields in terms of norm groups. Right. Because it doesn't see these other pieces. The norm group just sort of sees the abelian piece. Sure. Okay. So I guess that's where we'll leave off today's stream from. We've been defeated, but we will fight nonetheless to understand non-abelian extensions. This kid was 19. How the hell did he come up with such an abstract framework, especially little time before going to a duel? Yeah. True, some people are just built different. Well, what can I say? Yeah. Practice your pistol shooting and do group theory.